Welcome back to our biomass class, where we're delving deeper into the fascinating world of conversion of biomass resources into heat and power. This video was made with the support of InnoEnergy. Remember that this biomass energy course has 9 lessons. Lesson 1 is divided into several parts. Let's start drawing a map of raw materials and conversion processes to convert biomass into useful energy. Let's start analyzing the different composition and water content of biomass resources. Remember that it is important to know that certain feedstock are worth to be used in some processes over others. Therefore, let's start by analyzing the type of biomass raw materials according to their composition. A practical approach is to classify plants into 4 groups: lignocellulosic biomass, starchy biomass, sugary biomass, and oleaginous biomass. Cellulose, hemicellulose, and lignin predominate in lignocellulosic materials. Within this group are straw, wood, and firewood. After drying and resizing, they can be used directly in combustion processes. We call starchy biomass plants with a predominance of reserve polysaccharides such as starch or inulin. Within this group, there are cereals and potatoes. Sugary biomass has a high content of sugars in the form of monosaccharides or polysaccharides. Within this group are beets and sugarcane. Both starchy and sugary biomass can be used to produce liquid biofuels. Oleaginous biomass has a high oil content. Sunflower oil or palm oil are within this group. The vegetable oil can be used directly or for the synthesis of biodiesel. One of the drawbacks of some of these plants is that they can compete in the food market and endanger food security in poor countries. Using these plants to obtain energy implies a change in land use. Second-generation fuels are produced from lignocellulosic materials, avoiding the impact on the availability and price of food. Third-generation fuels are those produced from algae. Let's focus now in water content. Fresh plant tissue may have 90% or more moisture. Obviously, it cannot be used for burning. Wood logs, when cut, have about 50% water content. They must be dried before being burned. Wood pellets have a moisture content below 10%. We call dry biomass those below 13% moisture. We call semi-dry biomass those between 13 and 50% moisture. Fresh manures generally contain 70% to 85% water. This is an example of wet biomass. This is better suited to a biological process. The next step is to look for ways to convert each type of biomass into fuel and electricity. We call primary bioenergy to the energy content of biomass feedstocks before conversion. The first operation for vegetables is harvesting. The technologies are adapted to the type of forest or crop. For dry lignocellulosic materials, very few operations are necessary before using them in combustion equipment. Size reduction can be done, for example, by chipping. Regardless of pretreatment, biomass feedstocks must be stored. The type of transport depends on many factors, but it is always necessary. Logs, bales, briquettes, chips, and pellets of lignocellulosic materials can be used directly in stoves or boilers, where biomass is burned. Combustion releases heat. Using a Rankine cycle, mechanical energy can be produced from heat. Mechanical energy can be used to generate electricity. Useful bioenergy refers to the net energy generation, for instance in the form of electricity or heat, excluding transformation losses. We call direct utilization to the use of lignocellulosic materials without using any conversion process. Harvesting, pretreatment, storage, and transportation are operations also needed for other feedstock from plants. Transformation technologies are those that allow biological raw materials to be converted into fuels, which can be solid, liquid, or gaseous. Final bioenergy consumption refers to the use of biomass in different end-use sectors. In some cases, this category is equal to the biomass fuels. Solid biofuels are burned in stoves and boilers. Liquid and gaseous biofuels can be burned in turbines or internal combustion engines. The heat generated by biofuels in engines and turbines is transformed into mechanical energy. Transformation technologies can be thermochemical, physicochemical, or biological processes. Gasification converts solid lignocellulosic biomass into synthetic gas or syngas, which can be burned in a turbine or internal combustion engine. Anaerobic digestion is a biological process that converts wet biomass into biogas. Starchy biomass and sugary biomass can undergo a biological fermentation process to obtain bioethanol. Oleaginous biomass can undergo a physicochemical transesterification process to obtain biodiesel. Pyrolysis is a complex thermochemical process that produces gaseous, liquid, and solid fuels. However, it is more suitable for the production of chemicals than for the production of fuels. As you can see, the conversion of organic matter into energy is a complex area, with very different types of raw materials and transformation processes. This course focuses on the direct use of dry or semi-dry lignocellulosic biomass, as well as its thermochemical transformation through gasification or pyrolysis. Main feedstocks are logs, which can be produced in the forest or in distribution centers. Briquettes, which are compressed blocks of fuel biomass material. Straw bales, which are produced directly in the field as post-harvest waste. Wood chips, which are small to medium-sized pieces of wood formed by cutting or chipping larger pieces of wood of any size and shape. Pellets are one of the most popular solid biofuels nowadays. It is a fuel made from virgin wood dried and pressed into small cylinders, without additives. We will study the use of these fuels in stoves and boilers where they are burned. For the production of electricity, we will study conventional systems with the Rankine cycle. Pyrolysis and gasification are also included. Gasification is a technology in the pre-commercial phase for the production of electricity. Conventional pyrolysis mainly produces charcoal. Fast pyrolysis is a technology under development, which is aimed at the production of bio-oil. Bio-oil can be used also in internal combustion engines to produce electricity. The synthesis gas produced by pyrolysis is used to provide energy to the endothermic pyrolysis process itself.